Lesson 2.6, Compound Inequalities. Compound inequalities come in two forms. The first is a conjunction, which is a math sentence combined with the word and. It is also known as an intersection. And it is the part of the inequalities that overlap, the numbers that they have in common. And the second is a disjunction, which is a math sentence that is combined with the word or, also known as a union, and it is the total of both inequalities, everything that they have in common as well as everything that they did not have in common, and that should have been disjunction. Sorry about my typo. Okay, so intersections, if you think of where the roads overlap, that's the intersection, and a union is like a marriage where both parties bring everything to the table. Conjunctions can be presented with the word and or combined without the and present. So here we have two examples. As you can see, we have the word and. 3x minus 5 is less than 10, and 2x plus 11 is greater than 3. Or we have two inequality symbols. Both of these are conjunctions. And they can be solved in two different ways. Well, one way on this, two ways on this. So we solve each conjunction separately, or each part of the conjunction rather. So I have x is less than 5 and x is greater than negative 7. We have to keep the word and if it starts with and because it is a conjunction. Now with the two parts in one, what we do is rather than doing everything to two sides, everything has to be done to all three sides. So the left, the middle, and the right. So if I subtract 4 here, I subtract 4 here and here. Then when I divide by 3 here, I divide by 3 here and here. So this is 2/3 is less than x is less than or equal to 9. So 2/3 is less than x and less than or equal to 9. To graph the conjunction, we have our first example. So we had our three solutions. We had that. Let's see, we'll solve this again really quickly. So x was less than 5. And x was greater than negative 7. So what we do is we graph each separately first so that we're going to understand the concept. Okay, x is less than 5. We have an open circle on 5 and we graph this portion. When x is greater than negative 7, we have an open circle on negative 7 and we graph this portion. With our our conjunction, we had the word and. We need both parts of this. This is the overlap. If I were to take the parts that overlap, we'll have an open circle on 7, an open circle on 5, and as you can see, they have everything in between those two numbers in common. So that is all I will shade, is the overlap. Okay, now we don't have to do this on two separate number lines to begin with. I know I have an open circle on 5, and I know I'm going to shade that direction. I know I'm going to have an open circle on 7, and I know I'm going to shade in that direction. If the arrows are pointing towards each other and the word is and, I shade in between. Let's look at the other example. That's the same example. Sorry. So here we solved this, and remember we had that 2/3 was less than x was less than or equal to 9. Now when the x is already in between, this is very easy to graph. I have a closed circle on 9. I have an open circle on 2/3. And x lives in between the two numbers, so I shade in between. Let's look at some other examples. Okay, here are my number lines. This is a combined, so I'm going to subtract 6 in 3 places, and I get 0 is less than x is less than or equal to 5. I have a closed circle on 5. I have an open circle on 0. X lives in between, so I shade in between. Here I have two separate problems to solve. So I have 7n is greater than or equal to negative 21. Divide by 7, and I have n is greater than or equal to negative 3. I subtract 6 from both sides, and I get 5n is less than or equal to 15. Divide by 5, and I get that n is less than or equal to positive 3. Don't forget the word and. So I have a closed circle on negative 3. I have an open circle on positive 3. N is less than or equal to positive 3 and greater than or equal to negative 3, so I am shading the overlap in between. Okay, disjunctions have the word or, but there's no combination like with the word and. You'll only have them with the word or. 8x minus 10 is greater than 38, or negative 3x plus 5 is greater than 2. Okay, so I add 10 to both sides. 8x is greater than 48. I divide by 8, and I get x is greater than 6. I subtract 5 from both sides. I have negative 3x is greater than or equal to negative 3. I divide both sides by negative 3. I divided by negative, so I have to flip my inequality, and I have x is less than or equal to 1. I need to keep the word or between those two. To graph the disjunctions, we're going to do this in 3 parts again. I had x was greater than 6, or x was less than or equal to 1. X is greater than 6. I put an open circle on the 6, and I shade in this direction. Okay, now we can graph the other portion of the disjunction. I put a closed circle at negative 1, and x is less than that, so that graphs me this direction. And now remember, with an or, we're talking about a union. So it's both graphs combined, not just the overlap. So I want to put I wrote that with a negative 1. Hold on, there, I meant positive 1. Okay, so I'm going to put both graphs on the same number line. And since this is an or, I'm not doing the overlap, because as you can see, there is no overlap. I'm combining the two graphs into one. Okay. We have some more examples. If I subtract 12 from both sides, I get 4n is greater than 32. divide by 4, and I get n is greater than 8. I subtract 10 from both sides, and I get negative 12. N is greater than negative 48. Divide by negative 12, and I get n is less than 4. So I have n is greater than 8 or n is less than 4. N is greater than 8 will graph this direction. N is less than 4 will graph this direction. Because it's an or, I include both portions. Remember, or includes everything, and is just the overlap. Add 3 to both sides. 2x is less than or equal to 14. X is less than or equal to 7. Add 10 to both sides. Negative 8x is less than negative 72. Divide by negative 8, and x is greater than 9. So I have x is greater than 9, or x is less than or equal to 7. Less than or equal to 7, greater than 9. It's an or, so I shade both sides.